sort of newer pieces of the engine underneath Firefox to, again, speed up the thing, give it a fresher look. And then we're also moving to web extensions. Previously, for the whole 15-year history of Firefox, our extensions were built into Gecko, which was the engine that Firefox runs on. There's a thing called Zool. I won't confuse everyone with that. In the last several years, there's been a standard for how you extend browsers, which is called web extensions. It's using Chrome, it's using a lot of other browsers. So we're moving our model for extending the browser and building web extensions to web extensions. This is really good for developers because if you want to, one, it's using standards, JavaScript, and standard APIs. It's also, if you can essentially build it once and port it to a lot of different browsers versus having to learn the specific code for each browser. This also really, really helps Firefox performance. So it's moving everything into sort of a more standards-based, portable way. And we also have updated our developer tools. Anybody here do CSS? Cool. Anybody here seen our new CSS Grid Inspector tool? You should totally check it out. And coming in this next edition, we have something called the Css Layout Panels. We've added a new panel into the Firefox developer tools, which is just for CSS, and very specifically lets you inspect grid elements. Jake will actually give a little preview of this, but it's really awesome, actually. I wasted a lot of the day just messing around with tools. We also have new design and themes for our developer tools. So Firefox look got refreshed, so there are developer tools. And then because we really believe if we're telling people building web extensions is the right thing to do, we're actually building all of our developer tools as web extensions in Firefox. So instead of them being embedded in the sort of core engine of Firefox, they're now going to be a web extension. This makes it much easier, one, for us to do updates as we need them versus being tied to that 6-week cycle. It also makes it a lot easier for other people to contribute to the code. So web extensions, again, are based on web standards, so it's much, much easier if you're a web developer and you want to help contribute to tools or care about what our developer tools are like, you can actually contribute much easier on GitHub. So that's Firefox. We also have what we call the Emerging Technologies group at Mozilla. And if you can think of emerging technologies, it's something like an R&D team inside of Mozilla. And a lot of these sort of acronym-y sounding things that I've been talking about, like Quantum and Rust, have come out of our research group. So I'll give sort of a quick preview or a quick overview. How many people here, has anybody heard of Rust? Familiar with it all? Oh, yeah. Rust, how to start at Mozilla. It is a language that was designed to really increase parallelism and concurrency and security and sort of solve some of the core issues, particularly in languages like C++. We started at Mozilla with a lot of our engineers. Rust has now moved into essentially a large open source community. It's incredibly active. It's a fantastic community. Highly recommend if you like nascent languages. The Rust project is really fantastic. It is also what we're using to sort of rebuild the foundations of Firefox. So a lot of the other projects, Quantum, a few other things, are really centered around us using Rust. One of those projects is something we call Servo. And Servo is the sort of next generation browser engine that we've been working on at Mozilla. It's built in Rust. It's really, again, designed around performance. It is the core of this thing we call Quantum. I don't know how many more fancy words I can throw out. But, so there's Rust, we have Servo, which is our browser engine. We also have a thing called Stylo, which is our CSS style system that is based on Servo. It all sort of layers together. And then we have WebAssembly, which is really a new, it's built on the game stack plus WebGL. It was originally sort of designed for really, really high processor usage, things like web games. But there's a lot of uses for regular web development. If you have something that's heavy processing, heavy graphics, WebAssembly really speeds that whole processing up. It is in web standards. It has been adopted across all of the browsers. It's not live yet in all browsers, but it's working its way. It's in Chrome. And it's really become sort of the standard for putting essentially like the virtual CPU inside your browser. And then we have Webvr and A-Frame. So I think VR is pretty obvious. A-Frame is a framework that we've built to help people build more things in VR. Fabian will talk in depth about those things. And then again, I mentioned quickly WebRender, which is really, again, moving all that graphics processing to the GPU off of the CPU. And we're doing a whole host of other things. In addition to VR, we're looking at AR, so augmented reality, and then a lot of things around mixed reality, which is that combining of VR and augmented reality and sort of all the different ways that you can build things using those new technologies. So I mentioned you can always contribute to Mozilla. Just as I mentioned, you can always get Firefox Nightly if you want to walk on the wild side. We have our developer edition, which is a more stable 6-week preview for developers. We have web extensions. There's a GitHub repository for our web extensions where we have demos and samples of things that people are building of web extensions. You can build VR experiences. Anything that you're thinking of doing that's really processor heavy. We have WebAssembly. And another thing I haven't really mentioned is speech. This is a very, very new area that Mozilla is looking into. We have a program called Test Pilot where we sort of test experiments out. We have a project called Voiceville that's in Test Pilots. And then we have 2 projects. One's called Deep Speech and one called Common Voice. And what those really are designed to do is to open source voice and speech. Mozilla, again, we feel it's really important for the web to be open and accessible. And if you look at what's happening today with voice recognition and speech and a lot of those technologies, they are closed ecosystems. You have proprietary systems in Amazon, you have proprietary systems in Google. If you're a developer, you sort of get pushed into an ecosystem. We actually think all this stuff should be open and available, so we're building Common Voice is a voice database that we're asking people to contribute to so that when developers want to start building applications using voice, you will have a free and open set of voice data around the world, and we have 10 or 11 languages currently, but we're always looking for more. And then Deep Speech is really sort of our voice recognition kind of AI machine learning project. So those are very new things that we're working on, but again, those are more sort of open mission-based things that we're doing. We really want to make sure that people don't get stuck in proprietary ecosystems and forced to develop different things for every different system. So I know I threw a ton of terminology out at you. Every technology company has all kinds of code words. But I will say, we're going to get a little bit deeper into CSS. We're going to get a little bit deeper into VR. We're going to talk about web animation. I would say the thing to think about is go check out Firefox. Either download Nightly, download Developer Edition. Developer Edition now, like I said, is Firefox Quantum. It's so much faster. It's really, really cool. We're all really excited about it. Everybody else is too. And now I'd like to introduce Jing to talk about web design. Thank you.
Okay, so as Ali mentioned, I'm going to be talking a bit about web design this evening. This is the last stop of the Mozilla Developer Asia Roadshow, so hopefully we're going to close off with a bang. My name is Hui Jing. I'm from Malaysia. I played basketball for more than half of my life, and it actually kickstarted my web career. I now do front-end stuff in Singapore, and I love CSS so much that I will write blog posts about it. I also run a little CSS meetup called Talk CSS. But we're not here to talk about me. We're here to talk about Bruce Lee. You may be thinking, what on earth does Bruce Lee have to do with any of this? Did you just fall victim to clickbait? No, you have not. I'm going to be putting forth some ideas today that I don't expect everyone to agree with, but I do hope you will hear me out. Although Bruce Lee is known for his fighting prowess, he was also a deeply self-reflective man, and philosophy was an inseparable aspect of his martial arts practice. Content on the web behaves like water. Rather than trying to wrangle every pixel into place, we need to embrace the fact that content is meant to flow. If you make it fixed like freezing water into ice, it's not going to fit into all the different screens that people are going to use to view it. The digital age started in the 1940s when first electronic computers came about, and screens were introduced as an output device in the 50s. Before this, we've always used physical media as a means of visual communication, from writing on all kinds of surfaces to creating art, paintings, and sculptures, or even physical expression through dance and performance. But an electronic display is a proxy medium. Whatever we see displayed on a screen comes from data encoded as electronic signals. The heart of an electronic display is light. Light is transient. You cannot touch light. When it comes to the web, HTML was invented in 1989 by Sir Tim Berners-Lee. The first graphical web browsers were released around 92. CSS was proposed by Håkon William Lee in 94 and made into a W3C recommendation by 96. The reason I'm throwing all these dates at you is to remind you that digital is less than 100 years old. The web isn't even 30 yet. It is a millennial. Think about that the next time the web pisses you off. The web is really a very young medium, the likes of which we have never seen before. But what we have seen before are layouts like these. I've had a computer at home since I was a toddler and clearly remember the soothing sounds of a dial-up modem, the world of hit counters, web rings, guest books, ICQ, that sort of thing. Back in my day, every angsty teenager had their own blog where they would express their innermost thoughts and feelings in a lot more than 140 characters. The web had just started to take off, and not everybody wanted to spend a lot of time building their own websites from scratch. Most blogs at the time were hosted on blogging platforms where you picked a cool theme from a pool of available options. This was around the time when screen sizes started to get bigger than 640 pixels. Because we can't have extra space lying around doing nothing, we decided that sidebars were a great idea. Sidebars with links to blogs, other sites, maybe your contact information. If you were entrepreneurial, you could chuck an ad or two in there. By the mid-2000s, screen sizes had continued to grow, so instead of one sidebar, why not have two? But this particular layout wasn't easy to achieve. I mean, you could still build this with HTML tables, but come on. It was the 2000s. Cutting-edge CSS with floats was the way to go. No. You see, floats were not meant to be used for layout either. Like HTML tables, floats were also a hack, but they were all we had at the time to build the layouts that we wanted. Now, to fully grasp float-based layouts, you needed to know a lot of things. You needed to know about clearfix, about negative margins, have good arithmetic skills to calculate gaps. No, this was very difficult. But the web was exploding in popularity. Everyone and their cat needed a website. Then Apple made the iPhone, and the world went nuts. It marked the start of the mobile web as well as the exciting era of device testing. Ethan Marcotte coined the term responsive web design in 2010, and we learned the fine art of using media queries to create different layouts at different screen widths. By this time, a lot of people just threw their hands up in surrender and outsourced their pain to CSS frameworks instead. Frameworks that provide consistent options for things like layouts, UI elements, interactions, and so on. Consistent, but limited. If we choose to learn a framework and learn it well, all we get is the ability to maneuver within the bounds of the framework. In this day and age, browsers are constantly being updated with new features and bug fixes. The web is ever changing. at odds with fixed patterns of frameworks. I want to establish a new normal for the web, a normal where people don't expect websites to look the same on different browsers and devices, a normal where we embrace the fluidity of content and work with it instead of against it, a normal where we cede control of our designs to the browsers that render them. As Jen Simmons said, the hardest part is changing our thinking. The dynamism of the web and the lack of control we have as designers and developers over the final output is something that needs to become part of this new normal. People access information on the web predominantly through browsers, and we do have a lot of them. But they're powered largely by 4 main layout engines: Blink, Gecko, Edge, HTML, and WebKit. With the maturation of web standards, browser behavior is less unpredictable than ever before, though each browser still has their quirks. Features aren't all supported at the same time, but you know what? That's perfectly fine. If we accept this as a feature of the web instead of a bug, we've just opened up a lot more web design possibilities. Feature queries are key to making this approach feasible, and support for it is really good, with coverage in over 90% of browsers, including Opera Mini. The only browsers that don't support it are Internet Explorer and BlackBerry Mobile, and that is less of a big deal than you think it might be. This is how a feature query looks like. It's a conditional that checks if the browser supports a particular property or not. If it doesn't, the entire block within the at supports rule is ignored. This means we start off with a basic layout that works everywhere. It could be a float-based layout or a single column layout, maybe just largely browser default UI elements, that sort of thing. And then we layer on styles based on the features that we want to use. By organizing our code in this manner, the browsers that do not support feature queries or the specified property will still get styled, while those that do can get a fresh, different look. We're making use of the C in CSS. Call it cascading web design, and if this concept ever takes off, remember that you heard it here first. In this example, the layout on the left is what IE 11 users will see. The one in the middle is what Firefox users will see, because Firefox doesn't support CSS Shapes yet, but once it does, it will then look like the layout on the right, which is what current Chrome users see. And yes, this particular approach does require a level of familiarity with CSS, but it is not rocket science. It boils down to experience and the willingness to embrace CSS for what it is. And with that in mind, let's talk about what we can use for web layouts. First up is Flexbox and Grid. Now to me, Flexbox and Grid are like Jay-Z and Beyonce. They are great on their own, but together, they're on a different level of awesome. They both operate on what I call a container-child relationship, in that the display property is applied to a parent container that affects the layout of all the children in that container. Even though Flexbox has been around for a while now, I don't think we've really pushed it to its full potential. Yes, Flexbox is not as straightforward as, say, color or text decoration, but that's because it can do a lot more than those properties. As of 2017, the odds that somebody is using a browser which supports Flexbox is overwhelmingly high. The most basic use case for Flexbox is centering things. And when I first learned Flexbox, I hadn't fully grasped box alignment yet. So I used to center all my items by applying align item center and justify content center to the parent container, because all the blog posts told me to do so. And this technique worked just fine, but I only found out much later that if you only have one Flex child, Margin Auto does exactly the same thing. So when you have more than one item, an understanding of box alignment actually does make things much easier. So I have two items here, and say we want to center both of them. So if I set justify content center and align item center, you'll notice that justify content shifts it along the inline axis, while align item center aligns them along the block axis. Now Flexbox by default lays all its children out in one line without wrapping. And we can change that by changing FlexWrap to wrap, which did absolutely nothing, because wrap only kicks in when the content is longer than its container. So this looks sort of centered, but there's this irritating gap between the two items, and this is because there is a difference between using align items center and Align Content Center. Align Content actually controls the alignment of the both items as a unified block, while Align Items actually aligns each item along the flex line. When it comes to flex children, a key property is flex, and it's recommended that we use the flex shorthand rather than each of the individual longhand properties. The first value is for amount of growth, second value is for amount of shrinkage, and last value is the starting width before free space is distributed. Flex comes with some handy keyword values for commonly desired effects as shown in this table, and if we don't set a flex value on a flex child, its default behavior is cannot grow, will shrink, or 0, 1 auto. A common issue I hear is that it is difficult to create a grid system with Flexbox. And now the thing about Flexbox is that even though you can make a grid system with it, probably isn't the best idea to do so. Flexbox is more suited for laying out items in a single dimension where there isn't a relationship between the rows and the columns. Think of it like a daisy chain of flex children. So here we have a list of unstyled images. So once I apply display flex to it, all the items are shrunk and laid out in a single row. Now once I turn on wrap, they will revert to their original size because there's no limit to how much space they need to take up. If there's no space, the image will just drop down to the next row, the next flex line. So I'm going to turn on the border so we can see what's going on with the flex children. Instead of the initial behavior of can shrink and don't grow, we'll flip that around, make it 1, 0 auto, and you can see that the children now take up the width of the parent container. So if I make the images take up the width of their container, we now have a lot of options we can play with when it comes to designing this entire layout. I can actually do an Align Items Center and create this kind of a jagged look that we don't see all that often on the web. But I sometimes find neat grids a bit monotonous, so something like this could always be a design option we can consider. But if I really have to, I can create a neat grid look by standardizing the height of the images. But if I do that, you realize that some of the images have their aspect ratio screwed up. And we can compromise by applying a property called object fit, which allows me to crop the tops off the taller images. Now I can also change the direction of the layout by setting flex direction to column and giving the parent container a defined height. So I now got this horizontal scrolling thing going on, which again, we don't see all that often on the web. We can also play around with the alignment of the items. And now that the flex direction has changed, the block and inline axes have also exchanged position. So justify content center and align items center affect different axes. So again, we've come up with this jagged looking layout, and maybe this new age hippie layout isn't everyone's thing. That's fine. We'll remove the alignment code, make the flex children completely flexible, and make the images fill up the height of their container. So calc is an indispensable function I use when creating layouts. Here, calc lets me account for the margins of each image with respect to their container heights. And I can fix the width of the images to get something that looks like this. And these layouts that I just showed are a demonstration of what Flexbox can do out of the box. They are not hacks. These are native options we have when it comes to designing our layouts. Support for calc and object fit looks something like this, which is pretty decent, and they will only continue to get better in the near future. Honestly, the evergreen browser model is one of the best things to happen to the web. There is no better proof point of this than CSS Grid. CSS Grid is a feature that was specifically designed for doing layout on the web, and I don't think I'm exaggerating when I say CSS Grid is revolutionary for web design. And what's even more impressive is the manner in which it was rolled out. All the major browsers included CSS Grid in their March update this year, and if you look at the stats today, in just 6 short months, more than 70% of web users are using a browser that supports Grid. By developing Grid behind a flag, browser vendors could ask developers for feedback and test this new feature, but deter them from writing production CSS that wasn't fully baked yet. Jen Simmons said this in her talk at an event part a couple of years ago, that we need to translate ideas instead of transfer them, meaning that we can look for ideas, concepts and inspiration from everywhere, but we have to utilize them in a manner that best suits the medium we're working in. The grids we see on the web are usually regular, X number of columns all the way down, which was pretty much all the web could do without some serious hacks or JavaScript manipulation, but irregular grids are way more interesting. Which is why I'm really excited that CSS Grid is here, that we too can have irregular grids on the web and utilize them in a way that makes use of the dynamism of how browsers render things. So this is the basic premise of how Grid works. You define the grid and then you place items in it, either by yourself or you let the browser do it for you. Now there are a myriad of options for both these actions, which is what makes Grid so powerful and why some people may find it a little bit intimidating at first. So let's see how Grid works when we let the browser do the placement. With CSS Grid, we can do all the things we're used to doing, except more easily, like this fixed grid. The repeat function comes in really handy when your columns or rows follow a similar pattern, and in this case, I'm telling the browser to give me 5, 10, and white columns. It's fixed, so nothing changes when the viewport size changes. Grid also introduces something called the FR unit, which represents a fraction of the free space available in the grid container. In this example, I'm telling the browser I want each of my 5 columns to take up equal proportions of free space available, and so they shrink and grow together with the container, always filling up the width of the parent container. And this is something that is new. We've never been able to do this before with the min-max function. This function allows me to tell the browser that I want to cap the shrink at 10 ems, but if there is extra space, grow all my columns equally. Because of the cap, once there isn't enough space to fit 5 columns, the number of columns will decrease until everything fits. I didn't need to write a single meter query to get this effect. We can also define exactly where we want our grid items to go with the grid row and grid column properties. They are the respective shorthands to refer to a grid item's position. By default, a grid item will occupy one grid cell, but we can use the span keyword to define how many grid tracks an item should take up. We refer to the grid lines using their numerical index starting from 1 and not 0. Go figure. With the manual placement of grid items, there are a lot more interesting things we can do, and one of which is vertical white space. Now, the use of white space is important when it comes to layout design because it serves to balance the layout and bring focus to important content. In the pre-grid era, every HTML element had to be rendered one after another, and to achieve some semblance of vertical white space, we used hacks like spacer GIFs or JavaScript. But now, we can place items wherever we want in the grid we define. Think of it like placing pieces on a chessboard based on the grid row and grid column properties on the grid item. The cool thing about grid is we can also name areas of the grid using the grid template areas property, which I find great for vertical white space because you can create empty cells using the dot notation. Placement then involves telling the grid item into which area it needs to go into, like how I'm going to shift the 6th shoe, let's see if this works, into the grid area named F, because I suck at naming things. Now, another technique that makes the layout interesting is the use of overlap, because it breaks our expectation of regularity in a grid. We don't usually see overlap on the web because it used to involve a lot of tricky positioning rules and negative margins, or by just cheating, by processing the entire image before uploading on your website. Some people even use JavaScript to calculate positioning, but not anymore. Here's a simple example of overlap, just 2 circles behind a header. The code here is simplified to show just the placement properties, but to center the text, I actually applied a margin auto to the header. Pseudo elements are treated as children, so the 2 circles here are pseudo elements of the grid container, which have been explicitly placed to overlap. The header then overlaps these 2 circles. Now, the placement code here is a lot more intuitive than if we used absolute positioning, and you don't need to do a lot of complicated math to get the alignment just right, no matter how you resize the browser. Firefox is the best grid inspector tool in any browser, and the team is constantly working on adding more features to make our lives easier when we use CSS Grid. To toggle it, you click on the waffle-like icon next to the display grid on your grid container element. It will then show you all these grid lines, and you can see where your grid items have been placed on the grid, which is great for troubleshooting. And if you're using nightly, as Ali said, you'll have the layout panel in your DevTools, which gives you customization options like displaying grid line numbers and grid areas, as well as setting different colors if you're using multiple grids on the same page. One other dimension we need to keep in mind when designing for the web is feature support for each browser, and this will vary depending on how far back your support policy goes. For example, we can give browsers that don't support grid or feature queries a basic layout that looks like this. But for browsers that do support grid and feature queries, I can layer on this fancier overlap with vertical white space layout. Designing layouts on the web requires interpolative thinking on multiple levels. Web layouts can, and most probably should, morph as the viewport size changes. Our job is to make sure that the layout is most effective in the space it has to perform in. Also, there are more media queries available than just min width and max width. Like in this example, I'm using the min aspect ratio media query, which triggers my fancier overlap layout only when the aspect ratio is more than 1. Bruce Lee had put forth a criticism of martial art masters who built up an illusion of fixed forms, who attempt to solidify the ever-flowing. He called such practitioners insensitized, patternized robots who merely perform methodical routines as responses rather than responding to what is. Perhaps we too should allow our web designs to respond to what is. Perhaps we should be coming up with designs that listen to the circumstances of the different browsers that render them. Another useful tool we have at our disposal is Css Transforms. Although we tend to associate transforms with animations, which you will hear a lot about in the next talk, there is also a case to be made for static transforms, especially when it comes to layout design. Diagonals are a very dynamic visual direction, and when used in layout design, they create an active composition that implies movement or depth, and such art direction is totally possible on the web. Like in this example, we can use grid to place items, then use transforms to make them have this floating out of the grid look. But it's still fine to present a regular layout that works on older browsers that don't support grid or transforms. If you're familiar with image editing software like Photoshop, you'll find that a lot of image manipulation techniques can now be done in CSS as well. These are the 4 basic transformations in the 2-dimensional space, but they're also available when it comes to 3-dimensional transforms. There was an article titled "The Critical Request" that was published on CSS Tricks last month. It's a really good article on page performance, but what caught my eye was this beautifully designed header. It was an image on the actual article, but I felt it was something that could definitely be webified. So on a narrow screen, diagonals may not be the best idea, but once we have enough space, why not? Again, for browsers that don't support transforms or grid, we can still present a layout that doesn't use these properties with the help of feature queries. Remember, things on the web don't need to look the same all the time. 3D transforms also make for great visual impact, and the benefit of doing such design with text plus CSS is that it provides much better accessibility than just sticking the text in an image. With 3D transforms, we're operating on one more axis, which is the z-axis for depth. So there's some additional properties that we have, like backface visibility or perspective. So the perspective property controls how far an element appears to recede into the horizon. The smaller the value, the more dramatic the 3D effect. So if I change this value from 45 to 5, boom, you see that the horizon recedes much further away. Support for transforms is really good for both 2D and 3D transforms, but you don't have to use them if they don't fit your project. It's just good to know that this option exists and you can reach for it when the time comes. Magazine layouts are also chock full of interesting text, flow, shapes. Maybe we see this a bit more in fashion magazines, but shapes are not exclusive to those kinds of publications. This one's from Bloomberg Business Week. Sometimes newspapers do it too. Generally, the idea is to let text flow around something so it's not laid out in a rectangular shape all the time. The CSS module that allows us to do this is called Css Shapes. For now, we can only let text flow around shapes and images with a shape outside property. When you apply this property to a floated element, text will flow on the opposite side of the flow. There are 4 basic shape functions we can use to define define the outline around which we want the text to flow, namely circle, ellipse, inset, and polygon. These same functions are also used in the clip path property. So as you can see in the polygon example, both these properties actually share the same value. But shapes from images is what really makes me happy. The image has to have transparency because the alpha channel is used to calculate the shape. Pixels that fall below a shape image threshold property value are ignored so text can flow into that area instead. Now CSS Shapes is also one of those properties that fails really well, in that if a browser doesn't support it, it will just behave as if shape outside wasn't applied at all. Like what I'm showing you right now. This is because CSS Shapes isn't fully supported on Firefox yet. But if you check bug number 1040714 on the issue logs, you will see that the team at Mozilla is hard at work at this. But if you do use a browser that supports CSS Shapes like Chrome, you should see something like this, where the text is flowing around Bruce Lee and his fists of fury. Chrome has been supporting CSS Shapes for a while now, so their dev tools can show you how the shape threshold and shape margin properties are being applied. Now, a large swath of the world use writing systems that flow left to right, top to bottom, languages like English and Malay. But writing systems go in all directions. Chinese and Japanese can be written both vertically and horizontally. Arabic and Hebrew scripts flow from right to left. That's why we have the writing mode property, because it's the World Wide Web. But we're all creative people, right? So yes, the primary use of writing modes is to correctly present the various writing systems on the web. However, writing mode can also be used for art direction. Vertical writing is traditionally East Asian for Han characters, which are used in Chinese, Japanese, and Korean. The inline direction is top to bottom and text is read from right to left. But of course, when it comes to design, we can lay out text in all directions, if we so choose. This example demonstrates the writing mode properties' different values. There's vertical RL in red, where the text runs from right to left. There's vertical LR in blue, where the text runs from left to right. We can also apply a rotate to make the text face the opposite direction, like the example in green. But how can we use something like this in the context of a Latin-based writing system? Well, one idea is for headers. It might not be the best idea to lay out long chunks of text vertically, because that just makes it hard to read, but vertical text for short titles and headers can actually break up the monotony of a really long page. Other sole uses could be things like tags for blog posts where the information is not critical to the main content, so laying it out vertically doesn't adversely affect the reading experience. Also, depending on the number of links in your navigation menu, perhaps a vertical layout on a narrow screen could be a design option worth considering. Today, CSS really gives us a lot more creative choices as compared to when responsive design first became a thing back in 2010. Jen Simmons and Rachel Andrew are two people who have done a lot, both for developing layout on the web as well as educating the web development community about it. Rachel has a CSS layout course which is completely online, and Jen Simmons has a wonderful collection of demos which you can and should really check out. Speaking of demos, I think everyone should build up their own collection of demos, because that's the best way to learn and familiarize ourselves with CSS in general. This is a list of resources related to the things I covered in today's talk, and I'll share the slides for anybody who's interested. CSS has been around for 20 years now, and the last I checked, there were 501 distinct properties. And you don't have to know every single one of them. I'm just pointing out that we can achieve a lot more with CSS than ever before. I want to leave you all with one final Bruce Lee quote: that true observation begins when one is devoid of set patterns, and freedom of expression occurs when one is beyond systems. And I hope this will inspire you to create designs that truly embrace the nature of the web. Thank you.
presentation. I really enjoyed that. A bit hard to follow, unfortunately. All right, good evening, everyone. Welcome to Web Animations Made Fast and Fun. My name is Brian Bertels, and this is Daisuke Katsuka. We're both based in Tokyo, where we're working on animations in Firefox. We work on animation in Firefox, but I'm also involved in animation standards, and Daisuke also does a lot of work, in fact, all the work on Firefox's animation dev tools. So tonight I want to talk to you a bit about those two things, animation technologies and Firefox's animation dev tools. But before we get stuck into that, I'd like to hear from you. Has anybody here ever made animations for the web? Please raise your hand if you have. Okay, pretty good. Has anyone here ever used CSS Animations or Transitions? Oh, that's really good. This one I'm not so sure about. Web Animations API. Has anybody ever heard of the Web Animations API? Wow. Okay, one last one. Has anybody ever seen the Animation Inspector dev tools in Firefox? That's good. I was afraid you might already know everything, but that's great. Let's step back for a moment and talk about web animations. Animations are great. You can do all sorts of things with animations. You can tell stories with animations. This is a traditional Japanese fairy tale. Last year, Daisuke and I worked with a Japanese animator to make a web version of the fairy tale. This is just a slightly sped-up version of it. But you can do all sorts of things. This is all just using web animation technology. You can also use animations to explain user interfaces. So, for example, this is the new Firefox Quantum, and if you go to save a pocket bookmark, there'll be an animation which will tell you where the bookmark went to so you can find it again. Animation is often the most intuitive way to explain user interfaces. But also, animations can just be fun. I'm sure you all know this animation from Twitter, and it doesn't actually have a lot of purpose, but it's really fun. And that's quite important because if your users are having fun, they're going to be more engaged with your app or your website. They're going to have good impressions of your brand. They're more likely to recommend it to their friends. And all sorts of positive things come when your users are having fun. So animations are quite integral in making your users have an enjoyable time. But the problem with web animations is they're really hard. I think if anyone here has tried to make web animations, you know it just takes a lot of time to get it right. And so tonight what we want to do is introduce some of those web animation technologies, hopefully make it fun, but also show you how to make those animations really fast as well, make them really smooth, that is. And to do that, we want to show you the Firefox dev tools. We want to explain the web technologies using the developer tools that Daisuke has been working on. So we're going to get stuck into that, but we think they're really great. One other thing I'd like to point out, we're not the only people who think they're great. Rachel Neighbours is a famous animator who's actually with Microsoft, but just last week she was saying when she goes to make web animations and uses developer tools, she uses Firefox apparently. So that's a pretty good endorsement, I think. So we look forward to introducing those tools to you. So let's get stuck into it. We're going to do some live coding, but I realise that for some people, you learn more by doing and by fiddling than by just listening. So if you have a laptop with you, especially a laptop with Firefox installed, and you prefer to follow along with some of the code samples, then please just open up this URL, and you'll see the code samples there, and you can fiddle with them as we discuss it. So the URL is a bit.ly URL, 2 little y, big A, big F, big P, and little x. Hopefully you got that. I'll give you just a moment to type that in before we change screen.
What's the Wi-Fi password?
I don't know. you should see this page here. And if you've got Firefox installed, please open up the div tools as well. And you can press F12 to do that. So we're going to start with CSS Transitions because they're dead simple. CSS Transitions are basically a way to say to the browser, when the CSS on this element changes, animate it. All you need to do in order to make that happen is to tell the browser how long to animate it for. That's all. So we have a hopper selected here. When we hover over the logo, it gets bigger. And so in order to animate that, we just need to say how long to animate it for. So that's, we say transition, duration, say 1 second. We have an animation. And if you just type that in, congratulations, you're now a web animator. And the other thing that you'll notice is down here in the developer tools, that animation showed up. It's blue, which means it's a transition. And you can see a bit of the shape of the animation and how it starts slowly and then gets faster. And you can actually drag along the top to seek it backwards and forwards, and you can speed it up too if you like. And you can see the properties that are being animated down the bottom. So, transitions, dead simple. There are a few other knobs you can dial, things you can change. So for example, you can add a delay if you want a delayed reaction. For example, we can make it delayed by a second, and then it starts. And again, in the developer tools, you can see there's this line there indicating the delay. You can even make it negative if you want the transition to jump into the middle. So there you go, and you can actually see in the developer tools how it's being cut off. You can also change the way the animation eases in and out. This transition timing function property. The default is ease, but we can do things like this steps effect, which is kind of like a robot-like animation where it jumps in and out. And you can see that again in the developer tools, how that works. There's also, if you're really boring, you can use linear, which is just a straight line. Or there's other ones like safeties. Yeah, actually. We can also, we can't edit animations in the inspector yet, but we can use the rules panel to do that. So you can find the elements in the rules panel. Sorry about the screen. And then you can tweak the timing function there as well. Apart from that, you might want to animate more than one property. By default, every property gets animated, every property is transitioned. But you can, so the default is all, but you can say just do the transform, for example. Or you can also transition different properties differently. So in this example, we're changing both the transform and the opacity, and you might say do the transform over 1 second, but the opacity over 2 seconds. These are, all these properties are lists, so you can just match up the different property values to make them differently. And again, you see in the developer tools, they come up as different transitions. And that's a lot to write, so as with a lot of CSS properties, you can write it as shorthand as well. And that is really all there is to transitions. They're very simple, but you can actually do quite a lot with them. If you find there's something you can't do with them though, then you probably need CSS Animations. So I want to very quickly introduce CSS Animations. And we have an example here, and you notice there's a big difference with CSS Animations. It's not about just a simple change, but you actually define a whole story in animation using something called keyframes block. It has a name, and then you say at different times, at different points in the animation, what the different properties should be. With transitions, all we needed to say was how long it takes, but for animations, we need to say how long it takes and what the name is of this keyframes we're using. And if we do that, you can see we get this effect here, and you notice the colour is different. It's now a orange animation. That's because it's a CSS animation as opposed to a transition. We can use all the same properties that we have for transitions. So we can set the delays and the timing functions and so on. But there's a few extra properties that come with CSS animations. One of them is the ability to repeat the animation. So there's this very poorly named animation iteration count property. And we can use that to say, for example, that we And that's just showing us where we are within a single run of the animation. We can also change the direction of the animation with something called the animation direction. We make it run backwards by saying reverse. And you can see the graph goes backwards. And this thing goes backwards. And we can also make it go backwards and forwards using alternate. And that's what you expect. One other feature of animation, because we're not just animating an existing change, we're telling a story. Sometimes what we want to do is we want to say, at the end of the animation, stay at the last point. And so for that we have this animation fill mode property, where we say, if we don't add it, then the animation snaps back to where it was before we started. But if we say forwards, then it'll stick to the end. And if you've got a long delay and you want the animation to be stuck to its beginning position before it starts, then you have backwards for that, or both. As well as that, with transition, we only have a start value and an end value, and we have a separate transition for each property that changes. But with animations, we can mix them all together. We have lots of different values, and they all be mixed into the one. So in this example, we want to animate the background color. And you can see that that comes up as a separate property down the bottom, and it's actually, because it's a color, we show you the actual colors on the back. And I believe that is about all we have to say for animations. Animations are not much more complicated than that. Sorry, there was a requirement tonight that every slide has to have Bruce Lee in it somewhere. Yeah, so I think we can tick that box now. So the question that always comes up at this point is, when do I use transitions, when do I use animations? And to put it fairly simply, transitions are when you have a state change from A to B and you just want to animate it. Animations are basically for everything else. It's especially if you're repeating something like a spinner, or if you've got a very complex story where you're going not just A to B, but through all sorts of points along the way. But it's also if you have an animation that goes back to where it starts, like you've got a box and you want it to jump up and down for a little bit and then stop where it started. That's not really a state change, it's just a visual flourish. And so that's where you want CSS animation. If that still doesn't make sense, try using transitions. If it doesn't work, try using CSS animation. The next question, though, of course, is why don't I just use JavaScript? JavaScript has heaps of different libraries that you can use, and so why wouldn't you just stick with them? Well, there's different reasons to use JavaScript and different reasons to use CSS. The JavaScript, it's very powerful. You can do anything you want, basically. But the CSS has the advantage that it's very simple, just like we saw with the transitions. You can have animations in no time. On the other hand, JavaScript is more appropriate if you're doing very dynamic animations that are open-ended. Maybe they're moving somewhere new based on a mouse click or something like that. But CSS has a surprising advantage of being fast. And that's something which I need to explain a little bit about. Fast means smooth. It's a little bit controversial to say that, but I'll explain why. I realise that animation performance is not exciting for everyone like it is for me, so I'll keep it very short. But I think you'll agree, even if you're not engineering inclined, that you want your animations to be smooth. And so, to put it very, very simply, the one thing you need to remember is whether using JavaScript or CSS, whenever possible, try to animate, transform, and opacity. And there's a reason for that, and that's because when the browser goes to update those animations, if you're using transform or opacity, it can often, normally it can use the computer or the phone's GPU to update it. And that means it has a much better chance of doing it smoothly. That's true for every browser, not just Firefox. And that might seem really, really limiting. Just transform and opacity, what can you possibly do with that? The answer is, if you're a little bit creative, quite a lot. So the animation we showed you beforehand is all done with transform and opacity, except I think for the text. We used a filter animation to blur the text in. Everything else is just transform and opacity. Even at, say, a color fade, you can just have two colored elements and just fade one out. And then you can get a color fade that way. So you can actually get quite a long way with that. I hope in future that we will be able to expand that set of properties that we can optimize, like transform and opacity. And in 2017, they're the two ones which are going to give you the best performance. So transform and opacity. You can use them and you can still have runs smoothly for a bit, but then it stops and starts. And your users like Batman get really angry when they see this. What is going on here? We're using the right properties, but it's janking, I think was the word we got before. It's a janky animation. How do we fix this? The problem is, even though the browser can update the animation quickly, it can't, it's got other things to do at the same time. So it might be running other scripts, or maybe another tab is even running another script, or maybe it's doing some housework or something like that, I don't know. And so the animation just kind of stops while it's waiting for the browser to get around to updating it. What we really want to do is take that animation and move it to another independent part of the browser that can just run independently. And we can do that. All browsers can do that. They call them different things. Sometimes composite animations, off-main thread animations, or GPU animations. It's completely wrong, but they're sometimes called GPU animations. And all the current browsers are able to do this. But the condition is the browser needs to know everything about the animation to begin with, so they can do it. And Firefox will actually tell you when it's doing this. So we can have a look at a little demo of this. So in this animation we're doing transform and opacity. And if you probably can't see this, but there's actually a little lightning bolt mark here. And if you hover over the animation, it actually says down the bottom, all animation properties are optimized. That means it's actually running this animation on the compositor, this independent bit of the browser. It's not going to get interrupted. And if you look over here as well, next to each of these properties, there are these lightning bolt marks as well, saying that those properties are being optimized. The browser can't always do that. There's some reasons it might choose not to do that. For example, if we put padding left in, if you animate padding and transform at the same time, and one of those is optimized and one's not, they're going to get out of sync and it's going to look really funny. So the browser will see that and say, I don't think you want to be doing this transform animation on the compositor, and so it'll actually not do that. And in Firefox you'll see a little dotted line under the transform property, and if you hover over that, it'll tell you why it's not optimized like it could be. So if you find your animation's not going as smoothly as you think it should, sometimes you can get some help just by looking in the developer tools. So, smooth animations, no problem. Except there was that one condition. If the browser's going to run this animation in a separate place that's not going to get interrupted, it needs to know everything about the animation up front. And so that means this only applies to CSS Animations and CSS Transitions. So what do we do without JavaScript? Well, there's good news for that. There's actually a new API called Web Animations API just for this. Finally got there. This is, yes, Web Animations. And this is just an API that lets you say from JavaScript, here's the animation I'm trying to run, and then the browser can optimize it in all the same ways it does for CSS Animations and CSS Transitions. So a quick look at how that works. So this is the rough shape of the API. You just say what properties you want to animate and their values, and then in this case we're saying, and run that for 1,000 milliseconds, which is, in JavaScript you normally talk in milliseconds. The other advantage of using this API is that these animations actually show up in the dev tools as well, so you can inspect them and play them from there. And of course you have all the same options that you have with CSS Animations and Transitions too. You can set the direction and so on, and there's even a few extra ones like end delay, which is helpful for synchronizing things. For example, you can make that positive or even negative, and that will show up in the developer tools too. So that, yeah, there's a negative end delay. And again, you can use that to synchronize different bits. So that's Web Animations API. It's amazing, right? Yeah. The problem with Web Animations API is browser support. So at the moment, Web Animations is only supported. Oh, sorry, one last thing I forgot to show. You can also add an ID to an animation just to help you find it in the developer tools that will show up here. Sorry. So the problem with Web Animations is browser support. And at the moment, it's only supported Safari are in the process of implementing it, but I'm sure as soon as they release it, Edge will follow suit. So for now, if you want to use this in a production site, you want to use this polyfill as well. When you use the polyfill, it will fall back to the native optimized implementation in Firefox and Chrome, and in Safari and Edge are run in JavaScript. And if you want to know more about this, I wrote a blog about this about a year ago, and that will just explain a little bit more of the performance stuff for people who are interested in that sort of thing. Right, well that's about it for web standards and technology. Firefox Quantum, the new Firefox. Surely there must be all sorts of amazing animation things in the new Firefox that we've been talking about. Well, there's a couple of things. The first one is basically, I've already explained all this. What we have been working on, Mosby and I, and a number of others, is taking this Servo project, this is a Servo project logo, this browser written in Rust, taking its style system, putting it in Firefox. So you get this hybrid beauty here on the right. By and large, as a web developer, you shouldn't really notice any difference except that it's faster. We fixed a few bugs along the way. Things are running in Rust and parallel and all that sort of thing, but generally things should work the same as they always did. The other difference that you'll see though in this new Firefox Quantum is there's more animation in the user interface, this Photon code-named project. You might have seen this icon when you refresh a page. And would you believe this is actually done with Css Animations and is only done with the transform property? Well, how is that possible? Well, it's using this very long SVG file. And what we do is we simply move that bit by bit to the right using that steps timing function and then just hide the rest of the graphic. Yeah, actually this is a page explaining how it works, and if you look in the developer tools, you can actually see, well, you probably can't, but there's a steps timing function going along there. And you'll also notice that the lightning bolt is there, which means that this animation is running in this special compositor where it's not going to be interrupted. So even if the browser gets busy, that animation is going to keep running smoothly. And we've used that technique in a number of places in the Firefox UI, like these throbber animations. And interestingly, we use the Web Animations API to synchronize those throbber animations using a part of the API which I'll mention in just a moment. And so that brings us to our last part of this presentation, which is what can you expect from animations in the future, both in Firefox but in the web in general. And just very briefly, in terms of CSS Animations and Transitions, if you try to use CSS Transitions in an app or something complicated where you're using transition end events, you've probably had a disappointing time because sometimes transitions can just disappear. You can change the DOM and the element's gone and then the transition's gone and the transition end event never comes. There's something that we found a lot with Firefox OS when we were working on that. So we've added a new transition cancel event which will tell you if that transition's gone and you should stop waiting for it to finish. And that's shipping in Firefox along with a number of other events, and I expect other browsers will implement that soon. Another thing we've been working on is having animations that combine together and mesh together, and that's actually implemented in both Firefox and Chrome, but it's not released yet, and it's not yet available to CSS, only through the Web Animations API. And the other part is the part of the Web Animations API that ties CSS animations to Web Animations, so you can do things like, I think I have an example here. You can get all the animations in the document, whether they're CSS animations or transitions or web animations, and you can pause them all. Or you can inspect an element and see if it's animated using that same get animations. This is again something we've implemented, but not yet released. As far as web animations goes, we're working on improving that too, to make the API easier to use, so that you can, for example, leave out some of the keyframes, and also to add some promises so that you can do things like this. You can wait for the animation to finish easily and then do something after that. And there's some other things as well, some more ambitious proposals we're working on together with Google and Apple to, for example, have animations driven by a scroll and animations that run in work
want to talk a bit. For the tool, we will advance what is written here. I will introduce a few things quickly. First, keyframe is insertion. Actually, we can specify easy to each keyframes. We will visualize to understand this. Also, this feature was released in maybe yesterday or today's nightly build, so we can you can use now. And the next, grouping. Although currently Spectre displays existing animations on document sequentially, it will be more understandable if we handle animation which start at the same timing as group. For example, this part animated independently. We will treat this as a defined group so we can investigate each. Finally, this for now, also we focus to inspect that we want to support adding, removing, and editing. This means we can say it as authoring tool is rather than the inspection tool. In the future, we may be able to create a whole animation on the browser.
I think one more thing about DevTools is we're currently rewriting them in React and looking to move that code to GitHub. So I hope that you would enjoy contributing to that more easily. We can make the best animation DevTools ever. Yeah. That wasn't actually where I was supposed to finish. Yeah, if you want to find out more about any of these topics, there are some Twitter accounts. I think those get tweets once every 4 years or so, so look out for the next one. And today's slides, if you want to look up any of them that we introduced, you can get to these slides from this very awkward URL here. And thank you very much.
Why did loads? Since you've been waiting for a little while, don't hesitate to stand up. Do a bit of exercise, stretch your legs. It will take a minute. Too stressful? Too good? Can you hear me well in the back also? Yeah, good. So don't visit those URLs yet. We'll put them back. We'll also put them in the events page, so don't worry about it. You can still take photos and that if you want, but you really don't have to. So I'll talk about Webvr. I'll talk about VR. I don't know how many of you actually tried VR. So I'll start with actually what's the point of VR. Why should we want to do VR in the first place? Well, it's for all those things you really want to do, but you can't. It's not like you maybe not at some point, or maybe you will eventually. It's for stuff that never ever you'll be able to do, but you really want to do it. So for example, maybe you'll go to Mars, but probably not. But you'll never go to another galaxy. You'll never go to another solar system, and you might really want to. You'll never play with non-Euclidean space and really play by having something tangible. You will not play with four-dimensional objects. So I'm a diver, so I like to dive, but I can't dive to the Mariana trenches like 10,000 meters deep. Never going to happen. And yet I want to do that. Still, VR doesn't matter in itself. So I'm passionate about VR. I can't help myself. If you want to chat after, can talk about life, can talk about food, but somehow I'll somehow manage to plug it back. But it doesn't matter. It's not the time. It's not the VR experience that matters. It's the time after. What you can bring back to your daily life. What you'll be able to learn and eventually use for your work, to help friends, to help whomever. So it's not the time in VR. That's really the key. It's how you'll use it. So what's VR in the first place? You might recognize the holodeck from everybody's favorite science fiction shows. It's just making an entire world around you. It's just building an entire universe, whatever you want to do. And it literally works like this. So that's pizza. I don't know how many of you. Okay, we'll do a little game if you'll allow me. How many of you had pizza before? You'll have to keep the hand up. So for those who didn't stand up, so how many of you had pizza before? Some of you did not have, which is actually perfect. So keep your hands up if you really like pizza. Keep your hands up if you really love pizza. Now you can imagine the smell. No, keep your hands up. It's a little bit of exercise, it's fine. So you can imagine the smell, you can imagine the taste, and even the heat, all this. And now I see that some of you did not try. Imagine really, and that you have to explain to that person what pizza is. So not the recipe of pizza, not the taste, but really what's that warm feeling of having that slice of pizza after a really difficult day or whatever. Who amongst you, keep your hands up. Yeah. How many of you actually are confident that this feeling of this pleasure you had or whatever, you can transmit it to somebody who never ever had pizza? Like this. So, okay, I see some hands. We'll discuss after. I told you. And actually, we'll do the test. If you haven't tried pizza before, please, after the talk, do come. If you're confident that you can really transmit what pizza is just with words, you can't show the person won't taste the pizza, but he needs to have it. So that's the frustration I have with VR. No matter how much you know about the theory of VR, no matter how much you get the mechanics of it, the point of it, everything, until you haven't put the headset on, you don't know what VR is. So if you haven't tried VR, do come after the talk. We'll put the headset. I'll explain everything you want, or that I can actually answer to. But VR is really like experiencing VR is like testing pizza. It's until you've done it, you really don't know. You have no clue. So come after. So why actually talk about VR here and why with Mozilla? It's because because, as I said before, the point of VR, or how it works, what VR is building a world around you. So for example, the holodeck. So when I log into my system and I want to eventually modify something in that entire world or universe, I don't want to have any artificial barrier. Okay, if there are technical limitations, if there are some things that are just not possible yet, that's fine. But if there was some artificial limitation to that system, to this world I'm trying to be in, I can't do it, that's a really big problem. Because again, I'm building a world around me, around friends, around colleagues, around whomever is interested. And well, you can imagine some like more economical implications of what that is. You might recognize the guy in the shirt. Think about the implications. So I can actually complain about it. I can say, oh, that's really bad, blah, blah, blah. Or I can actually try to do something about it. And I'm not such a great coder, so I'm not going to like rebuild everything myself, do some really complex stuff. So what I did instead, because I really think it's an amazing new medium, is to bring people on board, friends, colleagues, future friends that don't know their friends yet, by organizing workshops. So by bringing people, having them bring their laptop, open the laptop, and start to do something. A workshop, a presentation. So that was in Brussels based. That was in the Brussels Microsoft Innovation Center. People just came, no idea what VR is. They try and they do something about it, just with like $5 cardboards, not complicated hardware, not fancy laptops, default on a laptop, $5 cardboards. So that went well, and I think it's really important because again, VR has an amazing potential, but in the end, you're still strapping over your head a black, even though cool-looking piece of tech. So I don't think it's a good idea to do this until you actually get a bit of how it works, what are all the layers under it. Not necessarily to understand everything, because that you can't, probably nobody understands, like from the physics of the processor to all the signal processing and all this, but bits of it to get that the result is magic, but the process isn't. And if you want to tweak, if you want to play, that's the thing. So I love doing those events. Some of those events like this are great. Some that was great. Sometimes, so that was in Brussels a few weeks ago. I organized a meetup, again, to democratize something, and the entire list of attendees was one person, me included. So that was a bit quiet, but it was great still. I had a good time. Also, I can explore and be a bit more focused. So sometimes a lot of people, sometimes less, but still every step along the way is a learning step. So why am I contributing in Mozilla, in Webview in particular? It's because if I'm building the holodeck, if I'm building an entire world around me, my friends, colleagues, whomever, I don't want any artificial limitation. So I want to be able to tinker, to play, to improve at every layer of the stack. I think that's important for pretty much everything, but even more if you're talking about building a world. So what do I actually do? As a contributor, so I contribute mostly to a frame and a painter. So I'll give a lot more detail about that after. So that means, yes, code. That means also just issues. So if at some point you have a piece of a frame, a painter, Firefox, that has any issue, has a problem, request, whatever, if you can actually describe as precisely as you can how it happened, when it happened, that really helps a lot. So issues also, discussing them, all this, that's not just code, that's inside. The documentation, because we're all exploring this new medium, so how we can help the community is by having proper documentation, lots of events, workshops, and also just chatting. I have only 3 hours for this talk, so I will not chat too much. But none of you finished, so that's good. But if you come on Slack, we are about 5,000 on the A-Frame Slack channel. Do come, do ask the question in public, but also if you have any issue, any problem, do ask in private. If I can help, I'll be happy to. And I'm also a freelancer on Webvr, working for small and large companies, and I co-founded my startup in Webvr a few weeks ago, so I basically just do Webvr. And I say just that there is plenty to do. So some issues to discuss, some empty slides, the importance of community, again, the Slack channel, the Twitter, with all also not just on the core of the framework, but what the community is building. Stack Overflow, obviously. Network. Okay, so those were slides. Okay, it doesn't matter. It were slides of lots of different events. So imagine lots of people smiling and doing trying things and meet different places. So that was the community part. That's a lot richer than that, but you'll have the slides after, you can see them. As also Jing said before, yeah, demos. So it really matters. That's a silly one, obviously. That's me playing soccer against myself, and I managed to lose. So I'm going to kick the ball, and somehow that's a 3D model of myself, and I block it. So yeah, but it worked. I lost, but it worked. So I strapped to. I have the usual controllers on my hand, so I can grab the ball and throw it. But I can also I strapped 2 more controllers on each feet using plastic wrap from my kitchen. That you don't want too much details. It worked. The demo itself, I think, was probably one of the first to do full body immersion in Webvr. It doesn't. What's important is it's a stepping stone. It's one way to help me also, but others to say, oh, that's actually possible. What can I do with it? And all the demos you do and share help you and others in the community to grow and move faster. So yeah, I'm pretty ashamed of the visual. I'm pretty ashamed of the plastic wrap on my feet. I'm pretty ashamed of a lot of things, but it helped me further. So and sharing it, not like just doing it in my little corner. It's really so yeah. Do demos. Clearly that helps. Do if you can document them and at least share them. Once you actually made demos, or you actually make a bigger project, eventually, yeah, whatever the size of the project, that's actually a lot of work because you have 3D assets, animations, sound. You can really spend a lot of time and obviously resources. So once you actually want to publish your content, to distribute it, you will want obviously to distribute to as many people as you can. Not everybody has a VR headset yet, so you clearly don't want to like stick to just one platform. And they were really well curated, nice platforms with some, some also downside. Like for example, if you're going to publish, you're going to have an approval process. I mean, I don't know how many of you publish on the App Store for mobile, but not that simple, takes time. And overall, if it's limited in the number of devices, your content is probably going to end like that. I don't know if you see the talk from Dietrich, but basically, people on average install 0 app per month. So that's not a lot. So if you can distribute on another platform, the platform that works on all devices, well, like the web, for example, maybe that's better for your own content. And is it introduced? Is it supported by all devices? Basically, yes. So it means the HTC Vive, it means the Oculus Rift, it means the Gear VR, it means Daydream, Google Daydream, and something that maybe not also, it's progressive. So it only works, if you only have a phone, for example, and you don't have the headset yet, you can still experience Webvr up to a certain extent. Obviously, it's not as immersive, but you can use Magic Window and see a bit how it would look like. If you just have a laptop, no VR kit, you already can see how it looks like. So that was in San Jose in October at the Samsung HQ for the first Webvr W3C workshop. That's this guy you might know. That's the rest of the team from Mozilla, the team from Samsung, the team from Google, the team from Apple unofficially. So they were there, but don't say they were there for Apple. So basically, Microsoft were there also working on it. So all the major browsers are there working on it and yeah, improving on the spec and the actual implementation on the specs after. So the web is not like just a way to put your content out there and port an existing your project you would have. It's not just a low resolution port to make it, I don't know, faster, or it's more. Obviously, I mean, the first one is all the techniques you're already familiar with, you already know and love, like progressive web apps, you can already do that. So it means if, for example, I'm on the pane and I want to work, or I want to just reload that your experiment I had, well, if I do it as a proper progressive web app, it refreshes, it's offline, it still loads. So all those techniques you can also bring back. Obviously, for everything that's networked, it's newly for free. I mean, all this you already know. And some stuff is actually, some features are dedicated to Webvr. It doesn't exist any other way. So for example, you can bring one VR experience where, I don't know, you were in a castle solving a quest and you gain a sword, let's say. And then you want to exit that VR experience to go to another one. And you don't want to break the immersion, going from one experience to the store that say, hey, here's an update about this, hey, here's an update about that. You want to go from one experience to the next with as possible a seamless transition basically, and bringing content. So if you're epileptic, close your eyes. Only able to, oh, and there is no network. Anyway, so you can go from one experiment to the next using a link where you basically traverse from one experience to the next. And that works today. Specifically on the tools, so I'll give more detail for each, but A-frame is the framework, so if you want to code that's A-frame, the inspector allows you to directly manipulate the content using your mouth as a more traditional 3D editor. The repository for all the components, and a painter that will also try after. So a lot of examples you will see. The first step is if you want to program for VR, you can. I think you should. I think that's one of the most interesting things to do. But if you don't want to, you can also just paint. So that was painted using a painter a few months ago by a friend. Again, to give you, it's really, you will have to try. I'll still try to explain it until you do try. That's the movement you would do, for example, to do the tail. That's that. So it's one-to-one. You don't have to think, oh, I'm going to project on a surface, oh, I don't have to. You just do that movement, and you will have that as a stroke. And also you can do that movement while you walk around. So you can see while you move your head. So all that is, you don't have basically two things. You don't have to, but you just focus on the content and you start to draw it. So in order to make your content, you don't have to program. You don't have to use your mouse. You can just be in VR and paint. I'll reiterate a few times, but again, it's all on the web. So a painter is on the web. You can click, that's a link. That's actually an iframe embedded in my reveal slide. So once you've painted that content, you can share it instantly to anybody. You can share it to just, if you actually visit that slide now, I don't recommend you do because you'll kill my connection, that's so precious, but if once you do after, then you will actually have this content all around you. If you switch in the cardboard, you actually be in that space without one line of code. Still, I think you should code, but I won't do that part because maybe I'll try it after if the connection allows, but yeah, that's a famous fake book. There is enough risk well, did anybody read it? Okay, it's a fake book. But there is a lot of content on Stack Overflow. What we use for the A-frame documentation is glitch, meaning that you can just go on the documentation, see a bit of code, see the result instantly, and just fork it. So all the examples, or most of the examples now in the documentation are forkable. So you just start to double with it with your normal laptop. Again, no need for something too expensive. And then you save it. You'll see it on your phone, on your Vive, whatever devices you have. Something important that was also briefly discussed on the previous presentation is that it started to be in 3D, so that's also an A-frame. I don't know if that, yes. strands of grass, and still it's not a problem. You can load it on your phone again. You don't do it now, but, and it will be smooth because yes, you can just paint without programming anything. You can use A-frame to have some kind of pseudo HTML to make your 3D content. But if you want to go further down the stack, obviously you can use JavaScript to generate those elements and animate them. But if you want to go even further down the stack, then you can directly write your shaders. So this way, all the graphical code you're going to write is going to be executed directly on the GPU. Meaning you can push a lot more content and still have something pretty smooth. Obviously, it's so dependent on the GPU. If you have a low-end GPU, don't put too much content. So you'll see that soon enough. That little example in the end was just, can I do that? I started with just this little flat surface and this cone. So just use that cone that I reproduced, I don't know, 50 or 200 times. And then I bend it over time and I put the color based on the distance. All that you can do another way, but if you do it using shaders, then all the code will be parallelized on the GPU and thus run a lot faster. If you don't want to, you don't have to, but again, you have access to all the layers of the stack. So the inspector allows you to manipulate the elements by rotating around the screen like a traditional 3D editor, by adding some behaviors or different visuals